Let's find the area of this irregular shape. This shape doesn't even have a name, much less a formula. So we'll break it into two pieces that we can deal with: a semicircle and a rectangle. You can see them here. And we don't have a full circle here, but if we did have a full circle, the area would be pi r squared. Since we only have a semicircle, or half a circle, the area formula would be half of that. Since this side is 20 and this side is 24, we can see that this distance here would be 4 centimeters. But that distance is the radius of the semicircle. So I can substitute that in and do the math. Now I know the area of the semicircle. Let's turn our attention to the rectangle. Here's the area formula for a rectangle. Plugging in the base and height gives us that area. But of course we want the total area, so we're going to take those two partial areas and add them together, and that would be the total. In some cases, you would use 3.14 for pi and get a decimal answer or approximation for this. And in some cases, you would just leave the answer as 8 pi plus 160, depending on the problem. Now let's find the perimeter of the same shape. We'll break it into a semicircle and a rectangle as before. If we had a full circle, its perimeter, or circumference, would be 2 times pi times r. But since we only have a semicircle, it would be half of 2 pi r, or just pi r. As we know, the radius is 4, and that gives us the perimeter of the semicircle. For the rectangle, you'll notice in the diagram that only 3 of the sides form the perimeter of the original figure. Adding those 3 sides gives me 48. And since we want the total perimeter, I'll take those 2 partial perimeters, add them together, and I'm done. If we were using decimals for pi and getting a decimal approximation, we would do that. If not, we would leave it as 4 pi plus 48. And let's not forget our units.